Good afternoon, students. As a first video of this online teaching, let us first see the major difference between a CISC and a RISC processor. The reason why this video has been posted as a first video is when we clearly understand the basic difference between a CISC and a RISC processor, it will be very easy for us to understand the ARM architecture, which is the next following videos. First of all, before we start the difference, let us recall the abbreviations of CISC and RISC. CISC stands for Complex Instruction Set Computer, whereas RISC stands for Reduced Instruction Set Computer. Now let us see what is the major difference. Coming to the first and the foremost difference between a CISC and a RISC processor. In CISC processors, we have variable sized instructions, which means instructions are of different sizes. For example, if you take 8086, you have 1 byte instructions, 2 byte instructions, 3 byte instructions, and so on till even 6 byte instructions. When you take 8051, you have 1 byte instruction, 2 byte instructions, and 3 byte instructions also. But that is not the case in a RISC processor. When you take a RISC processor, all instructions in the processor will be of a fixed size. All instructions will be fixed size. For example, when you take an ARM processor, all instructions will be 32-bit instructions. If you take PIC 18, all instructions will be 16-bit instructions. So, this is one major difference between a CISC and a RISC processor. Coming to the second difference, we know that every instruction undergoes 3 phases of execution. Whenever an instruction has to be executed, it has to undergo 3 phases. The first phase is the fetch, second is the decode, and third is the execute phase. Now when you take a CISC processor has multiple fetch cycles. What is the meaning of this is, the number of clock cycles taken to fetch a CISC instructions may vary. The reason is because since the instructions are of different size, the fetch timing, the time taken to fetch the instructions also may vary. For example, the data bus of 8051 is 8-bit. So if I have to fetch a 1 byte instruction, it may be fetched in 1 clock cycle. But if I have to fetch a 2 byte instruction, it may take a longer time. Similarly, if I have to fetch a 3 byte instruction, it may take even more a longer time. But in RISC processors, since all instructions are of the same size, the time taken to fetch the instruction will be only 1 clock cycle. For instance, in ARM processor, the data bus size is 32 bits. Therefore, the time taken to fetch a 32-bit instruction will be only 1 clock cycle. Now coming to the next difference. We'll move on to the next difference. In the next difference, a CISC processor allows instructions to be executed both from registers and from memory. Let me give you a clear example. For example, add A, R0, which means for addition you need 2 variables. One variable is available in the accumulator, the other variable is available in register R0. Whereas it also allows a second type of instruction, which is add A, at R0, which means it is adding 2 variables. One variable is available in the accumulator, the second variable address is available in R0. So if you go and look at R0, you will have an address which is the address of a memory location. So which means here the first instruction, add A, R0, is a register instruction, whereas add A, at R0 is a memory instruction. So both these type of instructions are allowed in a CISC processor, which means the operand for executing the instruction can either be in a memory or can be available in a register. So this kind of a flexibility is allowed in a CISC processor. But whereas when coming to a RISC processor, it allows execution or operation to go on only with registers. If I have to do addition, it has to be only adding the operands available in registers. I cannot add the operand that is available in a memory location. The only two instructions that goes to the memory are load and store instructions. Other than that, all instructions have to be available in the registers and cannot go into the memory to execute that instruction. So this is one kind of a rigid thing that is available in RISC but not there in CISC. Now coming to the next difference, your CISC processor has only very few registers because the operands need not always be in register. It can be in memory, it can be a direct operand, whatever it is. So for example, 8086 and 8051 has got just 8 registers. And in fact, 8086 has got only 4 registers. Whereas in case of RISC, most of the RISC processors have many registers because RISC processors only allow operations with registers. So that is the reason ARM7, which we are going to see in detail, has got 37 registers and all registers are 32-bit in size. Whereas if you'll be shocked to know that a PIC18, which is also a very commonly used RISC processor, has got 4096 registers, which is very flexible and which is very rigid and has got a very high performance. So the reason why this has got many registers is, I'm repeating once again because please make this point very strong in your mind. No instructions will be executed if the operand is available in a memory. The instruction will be executed only if the operand is available inside the registers. Now coming to the next very major difference between a CISC and a RISC processor is, a CISC processor has large instruction set. For example, if I take addition with register, addition with memory, addition with indirect data, and so on. If I take subtraction with operand available in register, subtraction with operand available in memory, subtract with indirect data, and so on. If I take addition with carry with registers, addition with carry with memory, and so on. So a CISC processor has many instructions and therefore more addressing modes. As we all know that addressing mode is nothing but a way in which an operand has to be fetched for executing an instruction is addressing mode. For example, I want to do addition. For addition, I need 2 datas. Where do I get the data from? That the address for getting those data is nothing but your addressing modes. So since there are many instructions, naturally there will be many addressing modes. But in RISC processors, you have reduced instruction set, which means if you have an add, it is only an add with registers. There is no add with memory, add with indirect data, and so on. Add means only add with registers. Subtract means only subtract with registers. Add with carry means only add with carry with registers. So what happens is, naturally the number of instructions reduced. And when number of instructions reduce, the addressing modes also reduce, because the addressing modes is only to fetch the operand from registers. So the job is made very simple and easy also for the processor to execute. So that is why the name reduced instruction set computer has been derived from, because less number of instructions are available. Now coming to the next difference, a CISC processor, the second phase you have fetched now next is to decode the instruction. Decoding is very complex in case of CISC processors. So when it is complex, automatically it will be also slow. The reason why it is complex is because the instructions are of different size, 1 byte instruction, 2 byte instruction, 3 byte instruction. So for different size instructions, different type of decoding has to be done, different kind of opcodes have to be generated. So decoding process becomes very complex and also slow. But whereas in RISC we have a uniformity to be followed, which means all instructions are only 32-bit in size when it is an ARM processor. So fetching a 32-bit and decoding a 32-bit is become very simple because it is all uniform, and since it is simple, it is also faster. Now coming to the very interesting concept of RISC processors is, we all know, pipelining. We studied about the introduction of pipelining in one of our previous classes. So with respect to pipelining, a CISC processor has pipelining. We cannot say CISC processors do not have pipelining. They have pipelining concept, but it is just for the namesake they have a pipeline concept. Therefore it is a poor pipelining concept. For example, 8086 has pipelining concept, but it does not have good performance over the pipeline. But whereas a RISC processor has a picture perfect pipeline concept. Let me explain to you with the help of a diagram. So here you can see that an ARM7 processor has a 3-stage pipeline. The 3 stages are, I would repeat once again: fetch, decode, execute, which means what? Fetching an instruction, decoding an instruction to understand what instruction it is and generating the opcode for it, and third is fetching the operands and executing the instruction. So these are the 3 stages. So now a picture, what do I mean by a picture perfect pipeline is, let me just explain this diagram to you. Here you can see that your fetch ith instruction, let us take the ith instruction, is fetched in time t, decoded in time t plus 1, and executed in time t plus 2. Now fetch has to be completed in 1 clock cycle, then immediately it moves on to decode, which is completed in 1 clock cycle, and then moves to execute, which is again completed in 1 clock cycle. Now the second instruction will have to be fetched in t plus 1, decoded in t plus 2, and executed in t plus 3. The third instruction, that is I plus 2, has to be fetched in t plus 2, decoded in t plus 3, and executed in t plus 4. Now a perfect pipeline would be possible only if all the 3 operations take place in 1 clock cycle. For example, fetching has to be completed in 1 clock cycle, decode has to be completed in 1 clock cycle, and execute has to be completed in 1 clock cycle. Even if one instruction, there is a delay in any one process, for example, delay in fetching or delay in decode or delay in execute, the entire pipeline will have a problem or will have a stall. Stall means a pause. Okay, and so that would make the pipelining imperfect. But this is not possible in a RISC processor because fetching is completed in 1 clock cycle. The reason is because all instructions are of one size. Decode is completed in 1 clock cycle because all instructions are of one size. And execution is completed in 1 clock cycle because all executions only deal with registers and no execution happens from a memory. So that is the reason we have a very perfect pipeline available in an ARM processor. Now coming to the overall philosophy of operation or performance of a CISC processor, we would say a CISC processor is flexible, but it is slower in performance. For example, all microprocessors are CISC, having CISC philosophy, but whereas all the RISC processors will not be flexible because it has got rigid size, rigid rules, and a rigid way of doing its operations, but it is best and faster. All microcontrollers are RISC based. Let me just explain to you with an example. For example, a computer which is used for general purpose is based on a CISC processors because it has to do various tasks and it has to be flexible, but we cannot expect a high performance in a computer. But whereas most of the appliances or CISC processors. For example, a mouse is a CISC processor because mouse need not do general purpose. It has to only take the x coordinate, y coordinate, and then it has to just do the task that it has been allotted with. But it is rigid and it has got a very high performance compared to a CISC processor. So this is the major difference between a CISC and a RISC processor. I think you would have clearly understood the difference between the both. And so once this is clear, next video we will see the in-depth ARM architecture, which is nothing but the entire architecture of ARM processor, so which is completely a RISC-based architecture. So let me just summarize what we have discussed in today's class. So RISC processors are rigid but have very high performance and they are very fast compared to a CISC processor. The main reason for this is because it has got very limited number of instructions, it has got limited addressing modes, and all the three phases of an instruction execution, that is fetch, decode and execute, completes in one clock cycle exactly. That is because it has got more registers and everything is happening in an orderly manner. So that is the reason we have very good performance whenever we use a microcontroller which is a RISC based processor. Thank you very much.